I'm Mark Kirk. I'm a member of the Centre for Off-Site Construction and Innovative Structures at Edinburgh Napier University, and we're here at Macar Construction Limited today to do some work on this truss system. The truss itself is for a domestic dwelling in Inverness. It's been designed by Neil Sutherland Architects for Scott Reid, who's an architect here, and this is going to be the ridge beam for his house. A ridge beam replaces traditional roof trusses, so all the weight of the roof of the house will be supported by this truss. The truss itself is 12 metres long by 1.2 metres deep, and it's constructed using locally sourced Douglas fir timber. The timber itself was acoustically graded by ourselves to make sure that it was of suitable quality for the job at hand, and also to make sure that we could optimise the system, because a truss system, certain areas are under different stresses to other areas, so the strongest timbers go in the most critical areas. Today we've been here to load the truss system itself and sort of make sure everything works okay. And on the bottom flange of the truss system, we've located some strain gauges. The strain gauges measure small incremental movements and changes in length, and this allows us to determine the forces that are acting on each of the members that they're attached to, so we can see that the system's working properly. The strain gauges are connected to the data logger in the centre, which records measurements every few seconds, and then we can use these and plot graphs to make sure everything's working okay. What we did today was we loaded the top cord of the truss with 2 tonnes of weight, distributed it so that it's a simple way to model it and to make sure that there was no areas that had a stress concentration. That can then be compared to the readings that we get from the strain gauges, and again it gives us a good idea as to how the truss will perform once it's put in place in the house.